scientists had found exoplanets that can potentially support life. K2-18b is a transients exoplanet, located 124 light-years away, that orbits an M-type star in the habitable zone. It's 8.6 times more massive and 2.6 times larger than Earth, making it a super-Earth exoplanet. Recent observations have shown the possibility of a thick, hydrogen-rich atmosphere containing methane and carbon dioxide, leading to theories about its potential for life. Here's a more detailed explanation. Discovery and location. K2-18b was initially discovered by the Kepler Space Telescope. It orbits a red dwarf star, K2-18, located 124 light-years away from Earth. Size and mass. It's significantly larger and more massive than Earth, being about 8.6 times Earth's mass and 2.6 times its radius. Orbital characteristics. K2-18b completes one orbit of its star in about 33 days, and it orbits within the star's habitable zone. Atmosphere and potential for life. The James Webb Space Telescope, JWST, has observed K2-18b and detected methane and carbon dioxide in its atmosphere. This has led to speculation that the planet may be a Hycean world, a hydrogen-rich planet with a global ocean. Some researchers also suggest it could be a gas-rich mini-Neptune or a rocky planet with a thick, potentially scorching, hydrogen atmosphere. Possible biosignatures. Some studies have also suggested the possibility of dimethyl sulfide, DMS, in the atmosphere, a molecule often associated with life on Earth. Debates and theories. The nature of K2-18b's atmosphere and potential for life are still being debated. Some studies suggest the presence of methane and carbon dioxide could indicate a magma ocean rather than a habitable ocean. The exact nature of K2-18b's atmosphere and whether it supports life remains a topic of ongoing research. We are now looking at another planet, Ross-128b. Ross-128b is a temperate, Earth-sized exoplanet orbiting a red dwarf star, Ross-128, located about 11 light-years away. It's considered a potential candidate for habitability due to its relatively mild temperature and the quiet nature of its star. Here's a more detailed explanation. Discovery and location. Ross-128b was discovered in 2017 using the HARPS instrument at ESO's La Silla Observatory in Chile. It's located just 11.007 light-years away in the constellation of Virgo. Orbital characteristics. The planet orbits its red dwarf star every 9.9 days, making it a closely orbiting planet. It's located within the star's habitable zone, meaning it could have liquid water on its surface. Size and mass. Ross-128b is estimated to be about 1.35 times the mass of Earth, suggesting it's a rocky planet. Temperament and quiet star. The red dwarf star Ross-128 is relatively quiet, meaning it doesn't emit as much harmful radiation as other red dwarfs. This, coupled with the planet's location in the habitable zone, makes it a promising target for the search for extraterrestrial life. Potential for habitability. The planet's predicted temperature range, -60 degrees Celsius to 20 degrees Celsius, could allow for the existence of liquid water. The quiet star also reduces the risk of radiation exposure, further increasing the potential for life to evolve. Future research. Ross-128b is a prime target for future missions, particularly those that aim to analyze its atmosphere for signs of life. The European Southern Observatory's extremely large telescope will be able to search for biomarkers in the planet's atmosphere. We also have the next exoplanet, TOI-715b. TOI-715b is a super-Earth exoplanet discovered in the habitable zone of its M-type star, TOI-715. It's about 1.5 times larger than Earth and located 0.083 astronomical units from its star, according to NASA Science.gov. The planet has a mass of 3.02 Earths and completes one orbit in 19.3 days. Here's a more detailed breakdown. Size and mass. TOI-715b is a super-Earth, meaning it's larger and more massive than Earth. Specifically, it's about 1.55 times larger than Earth. Orbital distance. It orbits its star at a distance of 0.083 astronomical units, AU, which is within the conservative habitable zone. Habitable zone. The habitable zone is the region around a star where an orbiting planet could potentially have liquid water on its surface. M-type star. TOI-715b orbits an M-type star, which are smaller and cooler than the Sun. Tidal locking. Since the planet orbits so close to its star, it is likely tidally locked, meaning one side always faces the star while the other side is in perpetual darkness. Potential for life. While the planet is in the habitable zone, its specific conditions for life are still unknown. Factors like atmosphere, magnetic field, and density would need to be considered. Discovery. The planet was discovered in 2023 according to NASA Science.gov. The last exoplanet we're going to talk about is K2-12b. K2-12b is a potentially habitable exoplanet located 40 light-years away, orbiting a red dwarf star. It is roughly the size of Venus and may have a surface temperature of 42 degrees Celsius, 107 degrees Fahrenheit, potentially allowing for liquid water. However, its atmosphere is still unknown, and it could be very different from Earth's, potentially having an atmosphere similar to Venus, no atmosphere, or a unique, unknown atmosphere. Scientists are studying K2-12b to understand how planets around cool stars retain or lose their atmospheres, which can provide insights into habitability across the galaxy. Here's a more detailed explanation. Location and size. K2-12b is about 40 light-years away, making it relatively close compared to other exoplanets. It's roughly the size of Venus, a bit smaller than Earth. Orbit and star. It orbits a red dwarf star, K2-12, and completes one orbit in about 12.8 Earth days. Temperature. Scientists estimate its surface temperature to be around 42 degrees Celsius, 107 degrees Fahrenheit, which is a few degrees warmer than Earth. Atmosphere. The planet's atmosphere is unknown, which is crucial for determining if it could support life. It could have an Earth-like atmosphere, a Venus-like atmosphere, no atmosphere, or a completely different type of atmosphere. Habitability. While the temperature suggests liquid water could exist on the surface, the planet's atmosphere is vital for determining if it can be habitable. Scientific significance. K2-12b is a valuable target for studying how planets retain or lose atmospheres, helping scientists understand the conditions necessary for life beyond Earth.